Okay, here we are asked to simplify sine inverse of the sine of 5 pi over 3. On the face of it, this looks like a pretty straightforward problem. However, this is not going to be equal to 5 pi over 3. That simply does not work, unfortunately. It'd be nice if it did, but it doesn't. Now, the reason it fails at the 5 pi over 3 is that inverse sine has a restriction. So if we're looking to do the inverse sine of something called r, that's going to give us some angle theta. All right? And we know that theta has to be between negative pi over 2 and pi over 2. Now, because of that, trying to cancel sine and inverse sine like this wouldn't give us a 5 pi over 3 because that's outside of our acceptable range for the values that we're allowed to get for our answer for inverse sine. Now, this doesn't mean that this is a completely wasted effort. We know that because of our restrictions on our answer being between negative pi over 2 and pi over 2, that our answers have to be in either quadrant 1 or quadrant 4. That's our positive pi over 2 here, this is 0, and here's our negative pi over 2 down at the negative y-axis. And if we were to look at the angle 5 pi over 3, that's going to be down here in quadrant 4. So we'd be going all the way around to get 5 pi over 3. But again, 5 pi over 3 is too big. We need it to be something between negative pi over 2 and pi over 2. So what we're going to do instead is look at that whole negative aspect of our angle and look at its measure clockwise instead of counterclockwise. And here that would tell us we would have a reference angle of pi over 3, but because we went clockwise, that would make it a negative pi over 3. That is within our acceptable range of negative pi over 2 to pi over 2. So our answer here for the sine inverse of the sine of 5 pi over 3 is negative pi over 3. Alright, for this problem we're asked to simplify tangent inverse of cosine of pi. Now we're going to treat this just like we would any other order of operations type of issue. We're going to do what's inside the parentheses first. So we're going to look at cosine of pi. Alright, so if you'll recall from your, I'm sure, masterful knowledge of the unit circle, here's our 0, here's pi over 2, and here's pi. If we look at the unit circle, so we'd be starting here at 1, 0, then we'd be going up to 0, 1 at pi over 2, and then we're down here at negative 1, 0 for pi. And you just need to remember that our x-coordinates are the cosine values. So for our cosine of pi, that guy is equal to that negative 1 here. Let me go ahead and rewrite that just to make it a little easier to look at. So we know the cosine of pi is equal to negative 1. So what we're going to do now is incorporate that inverse tangent that was out front of our cosine of pi. So we know this is inverse tangent of negative 1. And now the restrictions for inverse tangent is that our angle we get for our answer is going to have to be in either quadrant 1 or quadrant 4. Alright, so remember that this inverse tangent of negative 1 is going to give us some angle theta. Alright, so what this really means is that the tangent of that angle theta is going to be equal to a negative 1. And we need to remember that theta is going to be between negative pi over 2 and pi over 2, but not including. So that puts us again in either quadrant 1 or quadrant 4. Because of the negative, that means we're going to be here in quadrant 4 for our tangent. Right, so for the tangent to give us negative 1, that means we need to have the two legs of our triangle to be the same, or at least almost the same. Since we're in quadrant 4, our x values are positive, so that'll be positive 1, but the y values here are negative. And for the hypotenuse, that would be the square root of 2. Not super relevant, but it does help us to identify the type of triangle we've got here. So triangles with sides of 1, 1 and the square root of 2 for the hypotenuse is our 45, 45, 90 triangle, but of course that means we want to use radians because of the types of problems we're looking at here, and that would be pi over 4 for our reference angle. And if you find your triangle is a little too small to get good notes, always, you can always go back and draw a bigger one, like what we've got here. All right, so we know that our reference angle now is going to be our pi over 4 to give us our tangent of negative 1. So we just want to suss out what that would be for our actual angle measure. Now, because we want to be between negative pi over 2 and pi over 2, we're going to go clockwise to get our angle measure, which means this is in fact going to be negative angle, and since we already know the reference angle, that tells us here that our angle in question is negative pi over 4. So for the inverse tangent of the cosine of pi, our answer here is negative pi over 4. This problem here, we're asked to simplify the arcsine of the tangent of 5 pi over 4. If you don't like the arcsine notation, you can always feel free to write it as sine inverse. They are the same thing. So we can also look at this as the sine inverse of the tangent of 5 pi over 4. Regardless of which way you've chosen to represent the initial statement of the problem, we are still going to go ahead and follow order of operations and do what's inside the parentheses first, which means the tangent of 5 pi over 4. All right, so don't forget about that sine inverse out front, but we will kind of put him on the back burner for the time being. All right, so 5 pi over 4, that is going to put us in quadrant 3. So we were to look at our angle here, there's 0, pi over 2 pi, and 3 pi over 2 here. So this is going to be our angle 5 pi over 4. So here's our right triangle, and that means our reference angle here will be pi over 4. And that is equivalent to 45 degrees, so that tells us we have a 45, 45, 90 triangle, which means our sides would be 1, 1, and square root of 2. But because we're in quadrant 3, both legs of this right triangle would be negative. And the hypotenuse for these will always be a positive number, because it's going to measure the distance from the origin out to the end point there of our legs of the triangle. All right, so now we want the tangent of this particular angle, the 5 pi over 4. And that's going to be opposite over adjacent. So that will be, for our tangent of 5 pi over 4, negative 1 over negative 1, which will be a positive 1 for the tangent of 5 pi over 4. But remember, we're looking to go with the inverse sine of that tangent of 5 pi over 4. So that really means we want the inverse sine of 1. And the answer for any inverse trig function will be some angle, which I'll call theta. Feel free to call it whatever you wish. X, probably not the best idea since we already have x and y coordinates, but you want to get a little more creative with it and go with a phi or aleph or something else. That's totally acceptable as well. Now, since we know that sine inverse of 1 is going to give us our angle theta, we also know then that this means that the sine of our angle theta is going to be equal to 1. Now, there are restrictions on what theta is allowed to be because of the inverse sine. Here we know that theta has to be between negative pi over 2 to pi over 2. That's the restricted range on inverse sine. And the good news is that since we are looking at sine to be equal to 1, it tells us we're going to be on one of the nice cardinal points of the unit circle. So if we go ahead and draw our axes here, 0, pi over 2, pi, 3 pi over 2, and we can come back up here to 2 pi. Those are going to be outside of our range. But for sine to be equal to positive 1, that means we are going to be looking at the y values for positive 1, and that's going to happen right here at the point 0, 1 on the positive y-axis, which means our angle is this pi over 2. Since that is the or equal to part of the less than or equal to pi over 2, we know that theta then has got to be equal to positive, or sine of, theta has to be equal to pi over 2. Here we're looking to simplify the cosine inverse of the sine of 5 pi over 4. We'll start focusing on what's inside the parentheses there, and that is going to be our sine of 5 pi over 4. Now, 5 pi over 4 is in quadrant 3, so we'll get our right triangle drawn here. So our angle measure all the way around here is going to be our 5 pi over 4. But the part we care about here is our reference angle, which will just be a pi over 4. That's going to be same as 45 degrees, so we'd be looking at a 45, 45, 90 triangle. So that means our side lengths are 1, 1, and square root of 2, but of course the legs have to be negative, because in quadrant 3 both the x and y values are negative. So looking at the sine of 5 pi over 4, that sine is the opposite over the hypotenuse, so that's going to be negative 1 over radical 2. Right, so that's our sine of 5 pi over 4 taken care of, but remember we wanted the inverse cosine of that sine of 5 pi over 4, which means we're looking at the inverse cosine of negative 1 over the square root of 2. And keep in mind that the answer for an inverse trig function is an angle, which I'm going to call theta. And so if inverse cosine of negative 1 over square root of 2 is equal to theta, then this means that the cosine of theta is equal to that negative 1 over the square root of 2. And restrictions on inverse cosine tells us that theta has got to be between 0 and pi. Or more generally, we're in quadrants 1 or 2. And since we have a negative sign here for our value that cosine has to be equal to, this tells us that we're going to be in quadrant 2. So we'll go ahead and draw our triangle over here in quadrant 2. So now we know the cosine is the adjacent over the hypotenuse. With a little help from the Pythagorean theorem, we'll discover that our missing side length is 1, which tells us our reference angle here would be 45 degrees, or pi over 4 radians. But of course the reference angle doesn't help us. We need to know what that angle measure is from 0, so we'll go ahead and take a look at that now. So go from 0, positive y-axis is going to be our angle of pi over 2, and all the way to the negative x-axis would be pi. We're not going quite that far, so we're going to back up pi over 4 units from pi, which means this is 3 pi over 4 radians for our answer to the cosine inverse of the sine of 5 pi over 4. So 3 pi over 4 is within our acceptable range of 0 to pi. This is our answer.